Hi everybody, my name is Invita Ramella and I'm currently a sophomore here at UNC majoring in biology and psychology. So far I've completed Gen Chem and Organic Chemistry 1 and I've really enjoyed how chemistry connects to both real world and research applications. Outside the classroom, I currently mentor students to the UNC Biology Department as well as volunteer at UNC hospitals and work as a patient sitter, which has taught me patience, communication, and how to support students when they're feeling overwhelmed. I would like to be a chemistry ULA because I feel like I know how it feels like to walk into chemistry and think, this is totally new. How am I supposed to learn all of this in a semester? But I also know with the right support and the right study strategies, chemistry becomes a lot more intuitive and even fun at times. Helping students reach that point is something that I really care about. Through my experience as a biology peer mentor this semester, I've learned how to break down complicated concepts into simple, manageable steps, and how to help students build confidence even when they're struggling. Chemistry is a class where students often doubt themselves, not because they can't succeed or they don't know the topic, but because they've never been taught how to approach it in the right way. I want to help change that. My background in research from cardiovascular science to oncology has also shown me how essential chemistry is to understanding real biological systems. Most importantly, I want to help support students in developing better learning habits, such as how to practice actively instead of passively, how to recognize patterns instead of memorizing equations, and how to stay calm and organized when the content feels heavy, especially helping how to approach problems logically, step by step. Becoming a chemistry ULA would help me help students not only understand chemistry, but walk away feeling a lot more confident in their abilities and themselves as learners. This is the part of teaching that I find most meaningful. We're going to be doing problem 2 today. So question A is asking us, what is the stereochemical label for the center S1? S1 is not exactly a chiral center, but it instead shows EZ chemistry. Each of these four groups coming off have a different higher priority. So what you would do is you would start at one side of the double bond, and you would see which one of these would have higher priority. From this normal alkane to an alkene, the alkene would have higher priority. On the other side, when you look at O and F, looking at the periodic table and seeing which one has a higher number on the periodic table, we would see that F has a higher number than O. Which when we scroll back, we can see O is labeled number 8 and F is labeled number 9. Since F is higher, we would label this as the higher priority group. Since for this bond, the higher priority groups are on the opposite sides, we would classify that as an E alkene. Leading us to say that this is the answer. For question B, it says, what is the stereochemical label for the stereocenter S2? When we're looking at S2, we can see that this OH group is coming off on a dash, which is saying that it is behind the plane pointing backwards, which would mean that our hydrogen, our implicit hydrogen coming in, would be on a dash. Sorry, a wedge. So when we are labeling priority, what you would do is you would go around the stereocenter and see which groups would have the highest priority. Going one carbon out, we would see that this carbon compared to this carbon, compared to the hydrogen, and compared to the O. When looking at the number of all of these groups, an O would beat a carbon. An O has a higher number compared to a 6 carbon, making this label number 1. Then we would know that hydrogen has the lowest number compared to all of them, since we see that C has a 6, O has an 8, and hydrogen is labeled as 1, making this number 4. When we're looking at these two carbons, we would then see what is attached to these carbons. This carbon is attached to one carbon and 2 hydrogens, since we have 2 implicit hydrogens coming off. This carbon we would see is attached to one carbon over here and one carbon over there, as well as 1 implicit hydrogen. Since these would even out, next we would look at the comparison between the carbon and the hydrogen. We would see that the carbon, once again, has a higher number than hydrogen, making this beat out this, making this side 2 and this side 3. Then we would label from 1 to 3, leaving out our 4 for now. Now this would be in the clockwise direction, making this an R stereocenter. But since our hydrogen is not implicitly on the dash, as it should be, and is instead on the wedge, we would have to switch that rotation, making this the opposite. So instead of R, we would actually have S. That would give us, for stereocenter B, stereocenter S2, we would have